Welcome to the future.
Welcome to the Muxall Open IoT channel. I am your host, Michael Crane. Okay, so in today's video, we're going to be doing some 0 to boiling standard temperature measurement tests on our sample probes that we got from the manufacturers that are building the Muxall BBQ Controller or the Muxall Pro BBQ Controller meat probes. And so I'm going to show you these probes real quick, but before we start that, I wanted to show you the specs that the manufacturer has got. So these were the specs. It was going to be used for food. I didn't really care if it was a PT100 or PT1000, but I did want it to be a Class A. And I'm not really sure if they have a Class A PT1000. So anyway, I threw that out there. The probe length needed to be between 140 to 150 millimeters, the diameter 3 to 4 millimeters, and I needed food grade stainless, and even though I Googled it and it said this was good for food use, I think for utensils, I think the stainless steel 316 was clearly the right choice. So all the food probes will be made of stainless steel 316. The temperature range, so most of the barbecues only go up to 500 degrees Fahrenheit, so 300 degrees C was more than enough. I forget what that is. That's about 650 degrees Fahrenheit. Of course, it needed to have a sharp tip on it so you could plug it in the meat, and we wanted it 4 wires so we could do a true Kelvin measurement, which is a bit overkill for the for a barbecue. But, you know, if you got it, why not flaunt it, right? I wanted the cable length to be about 1 meter to 1.5 meters. And I originally spec'd out Teflon, and later in the video, I'll tell you what happened there. But this first testing was for the accuracy of the probe. And the second testing, which will be in a following video, will be on the durability of the probe, all right? And the sheath, of course, is also going to be stainless steel 316, and this is all for the wire. I'm sorry about that. You probably noticed it, but anyway, so the wire should be 1.5 meters Teflon stainless steel 316 sheath. If you're wondering what that is, that's the braided stainless steel inside the wire that's protecting the wire, and the temperature ranges, of course, to 300 degrees C. So, okay, with that being said, so here's our first probe. This came from, and I'm going to mess up the names of these companies, so just bear with me. But this is the Muxall Best probe, and it's pretty nice. It checked all the boxes. This isn't a really good picture of it. And I'll see if I can find a better one later. But anyway, it's got the stainless steel. I know it's hard to see in the video here, but you know, so it's got the stainless steel probe. It's sharp. It's got stainless steel handle. It's got strain relief spring there, and it's Teflon over stainless steel with Teflon wires inside. So here's the Yi-Chun probe, and it's got a different, man, these pictures are horrible, aren't they? I found a little better picture of it. It's actually in the test setup, which we'll see more of later in the video. But you can see, so the Muxall Best probe is like this guy right here, and you can kind of see it's got a clear plastic Teflon coating over the stranded stainless steel braiding, right? And the 4 wires are installed. And then the Yi-Chun probe that we're looking at looks like it's a white opaque plastic, or white opaque Teflon coating the over another stainless. It also has a stainless steel braid. At least I believe it does. I'll have to check later. But it has the Teflon coated wires inside there. Okay, and that's kind of a little better picture of it. It's kind of, I didn't really have a good picture. Looking around, I couldn't find anything. Okay, so that's the Yi-Chun probe, and you can see it's got a little bit of looks like shrink wrap right here. I don't know about that, but it also has a sharp tip. It's nicely brazed right there for water tightness, and I'm guessing they put that shrink wrap on there for water tightness, even though if you remember from the spec, I did not spec out that it needed to be watertight, right? Okay, so moving on. So the next one is the Hain Shinny probe. I don't know if I'm pronouncing that right, but it also has a white opaque Teflon coating on it, and you can kind of see the Teflon coated wires. All right, so you can see it's got this plastic handle on here, and if you remember from the specs, it needs to be the probe itself, which is the metal part that goes in the food, needs to be rated up to 300 C, and the wire insulation and sheath need to be rated up to 300 C. And I didn't expect Teflon to be rated that high, but you know, as long as it can handle 400, 500 degrees, we should be good, right? So anyway, I'm guessing that handle is rated up to the temperature that we specified. We'll have to find out when we test, huh? Okay, so the next one is, let me pull it up here, is the Xinhua Xinrui. And I apologize to all my Chinese viewers that I just absolutely tortured that name. I think one of them is actually a name of the town they're in, but I don't know. Anyway, so here's their probe. It's nice. This probe is sharp as a needle. I mean, they really sharpened it. It's almost dangerous. It also has, it's like the Zalbest probe. It's got the the clear Teflon coating over the stainless steel over the wire, and I showed you a picture of that earlier. I apologize, these pictures aren't very good. But it also has a spring strain relief. Yeah, it looks pretty good, doesn't it? Okay, so those are the 4 probes we're looking at. So let me show you the test setup here real quick. So this is basically the test setup. I have my Fluke 87.5 inside a pot, and I have all the probes. I've got another picture, hold on. So I have all the probes basically tied together using the thermocouple off the Fluke multimeter, right? And the Fluke multimeter is just to kind of, be a sanity check. The barbecue controller is more accurate than the Fluke. Fluke is a well-proven device, so I want to make sure if something's reading crazy that the Fluke gives us a, kind of a sanity check, right? So, and I wrapped them up like this so they should all read the same temperature, right? Being wrapped up like that. And what I'll do, there's going to be 2 different tests. I'm going to fill this up with ice first, let it melt and let everything kind of stabilize. Then the second test, I'm going to throw it on a burner and heat it up to boiling. And so if you know your standard temperature, pressure measurements for water, at sea level, of course, water freezes at 32 degrees Fahrenheit, 0 degrees Celsius, and boils at 212 degrees Fahrenheit, 100 degrees Celsius. Okay, those are accepted standards worldwide, so we should be able to. That's a pretty good range for this probe, from freezing to boiling. Actually, a lot of people don't cook up to 212 degrees Fahrenheit, so this will give us a good range to see how well the probes read. Okay, so the first probe we're going to look at, we're going to do the freezing setup first, and might as well show you the results while we're at it, right? So since I introduced the Zalbest first, we'll look at it first. So you can see all the probes are plugged into it, and I could only had one prototype controller, so I couldn't measure all the temperatures on all the probes at the same time, so I had to keep swapping the controller between the different probes. So you're going to see 4 different pictures. The Fluke's reading 33.6. It's 1.6 degrees Fahrenheit off, and this should be reading 32. But you can see the Zalbest probe is reading 32.9. Okay, we're talking about Yi Chun. Anyway, so you can see it's reading right at 32.0 degrees. Yeah, you can't ask any better than that. And if you're wondering, yes, I did take several readings, but it's settled on this, and I can kind of show you the. So yeah, so it was between 32.2 and 32.0, but after it settled down, it went to 32.0, and I actually let them all settle down, and I have a composite picture with all results in it, with the best results from each probe. I took the best result from each measurement to show you on the video. Okay, so next on the list is I was already showing it to you, is the Haynes-Shinny probe that we looked at, and it also dropped down to 32.0 degrees Fahrenheit. You can see the fluke is still, it was kind of bouncing around. And I'm sorry I didn't create a video of this. I was in a hurry. I had a Kickstarter running. I just didn't have time to set up and shoot a video and edit it and that sort of thing. But you can tell this pot is sweating. So this water is well settled, and it should be right at 32 degrees. So 32.0 was for the Haynes-Shinny, so that was good. And for the Zinru probe, it also got to 32.0 degrees, and you can see that the fluke is, if you look at the fluke, it's bouncing between 33.0 and 36, or 33.6. I'm sorry. So it was always like a degree off. Not really sure why, but I do believe it was within the spec of the fluke, so I'm not too worried about it. So yeah, so 3 of the probes did good. The Zinru probe was the only one that actually dropped to 31.9. It was the only one that actually went under 32 degrees. Is that good? I don't know. But I just thought it was interesting. So that was our 32 degree Fahrenheit test. And 3 of the 4 probes did well. I mean, they were spot on. Let's look at the boiling test real quick. Here's the setup for the boiling test. I basically took the same bundle, tied them to a stick, put the pot. That's actually what you deep fry a turkey on. It's just a big burner. And my propane tank right there. Yeah, so we have the fluke plugged in, Muxall Pro BBQ Controller prototype plugged in. And I do believe the flame's running now. That's why it's reading hotter than room temperature. And I have another pic here. Yeah, so as you can see, so now the fluke is reading 208.6, which is really close to what this is the Zinru probe. So I think what I did is, after I finished the freezing test, I didn't bother changing the controller out. I just stuck it in a pot, or stuck it in the the boiling water, or set it up for the boiling water test. But now you can see they're very close. I don't know why the fluke was reading so a degree off in the freezing test. So anyway, this is the test setup. I didn't get any of them to get to a 212 degrees, even compensating for atmospheric pressure, because I'm not at sea level. I'm about, I think, 300 feet above sea level. But even at 300 feet, let me back up. The difference between 8 and 12 is I'd have to be in a mile-high stadium in Colorado to even get close to that kind of atmospheric pressure change. So for water to boil at 208 degrees Fahrenheit. So I kind of Googled around, and the only thing I could figure out is maybe there's some contaminants in this water that's changing the boiling point. I don't know. So before I waste a lot of your time, I found the boiling test to be inconclusive. I'll go ahead and show you the other controllers. They all read about the same, except for the Zhao Best one. Okay, so for the here's a close-up of the the Zinru probe test, and I did a close-up so we could read the temperature a little better. I wasn't sure I was going to be able to read it when I was taking these pictures, so I did close-ups on them. But you saw the test setup, so it's the same for all the different probes. So yeah, so it was reading 208, very close to the fluke. That was a Zinru. Okay, and since we're looking at these backwards, I'm going to go through them backwards. So the next one is the Yi-Chun probe, and you can see this fluke was actually bouncing around quite a bit. I wish I had a video of it. It was all over the shop. I don't know if this thermocouple reads pretty fast, so I don't know if it's the air bubbles in the water that's made it jump all over. But anyway, yeah, so it's reading 208.8, which is about 0.3 of a degree difference than the Zinru. Okay, and then the Yi-Chun was reading 208.5, which is, I think, exactly what the Zinru was reading. And yeah, as you can see, they're all going to read 208. I think I mentioned that already. Okay, and then the last one, the Zalbest, was a degree off, or almost a degree off, 209.1. And as you can tell, the fluke was bouncing all over. It's now reading 206, but believe me, it was all over the shop. Yeah, so the Zalbest was the most out. Not exactly sure why, but yeah, it was almost a degree out on both the freezing and the boiling test. Or at least the boiling test, it wasn't reading the same as all the rest of them. So, here's kind of the summary. Here's a summary of the boiling. This is a snapshot of all 4 test results. I just put it in one picture. Yeah, as you can see, the fluke's all over the place. Anywhere from 206 to 208, so yeah, not really sure what was going on there. But you can see the temperature probes were 208.5, 208.2, 208. I don't know what that was, 5, I think. And then we have a 209. I guess that's only about a half or 5/10 out, or a half a degree, because it was 209.1. Still, it was the furthest out. So we have 3 that are reading real close, which are the exact same 3 that we're reading close with the freeze test. So we have 32.0, 32.0, 32.0, 32.9, right? It's almost a whole degree out on that one, 9/10. So I have confidence in the 3 probes. The Zalbest was the only one that didn't really measure up, so to speak. So I'm going to throw out this boiling test. I found it inconclusive. I couldn't explain why none of them were reading 212 degrees Fahrenheit. If someone knows, post it in the comments. I'd be very interested to know. But the freezing test was a success. So I like that. So at least we got one good, and this is the only temperature standard I know of, is freezing and boiling water. There might be other standards out there for testing probes, if anyone knows, or testing temperature measurement devices. If anyone knows, let me know. I'd be very interested. I never did Google it. I could probably look around, but the freezing water and boiling water was a pretty cheap test, and it's been well documented and standardized. So at 32 and 212. Okay, so what's the conclusion? Well, the conclusion is, unfortunately, the Zalbest one, I'm going to have to figure out why it's not reading right. The advanced temperature measurement system in the Muxall Pro BBQ Controller has an accuracy of 0.1%. So yeah, we don't want a degree off. That's not good. That's out of spec, actually. So yeah, we're just going to move on to the next testing, and the next testing will be the heat test, or the smoke test. I'm going to put it in the oven and cook them and make sure that they're going to behave themselves up to 400 degrees Fahrenheit. Don't forget, you can support the Muxall Open IoT channel by donation using a credit card and PayPal, or by purchasing products at the Muxall store. Details and links are in the description under this video. Well, that's it for this video. If you liked the video, give it a big thumbs up, that helps, and hit the subscribe button. That really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching, and I'll see you next time.